Good morning, students. I hope you are all fine and safe. Now I am going to take the math class. Before that, we recall some topics that we have already learned in the previous classes. So, in maths means first we think about the numbers, isn't it? Numbers. What are the classification of numbers? Natural numbers, whole numbers, integers. Integers. So, what is natural number, ma? Natural numbers means it starts with 1, 2, 3. It is a positive numbers. No? Whole numbers. Whole numbers means it starts with 0, 1, 2, 3, etc. It is also positive numbers. But in integers, both the negative and as well as positive numbers. Minus 3, minus 1, minus 2, minus 3. These are all negative numbers. We already learned this. So, negative numbers means it is in the sign, minus sign. So, negative integers means both the positive and negative numbers are included. So, for the next one is a rational number. So, we have already heard this rational number. We have already heard this word rational number. Today's topic is rational number. Okay. Now, we discuss about the rational number. Rational. So, first I draw one line. You know, this is a number line we know. Okay. So, 0, 1, 2, 3, 4. Here, minus 1, minus 2, minus 3. It is a number line. Can anyone tell me what is the number lies in between the 0 and 1? So, someone say, Miss, here 0 to 1, this is 1 by 4, this is 1 by 2 and 3 by 4. Someone said, Miss, no Miss, 0.1, 0.2, etc. Miss. We know this. In between the 0 and 1, 0.1, 0.1, these are all decimal numbers, as well as 1 by 4, 1 by 2, 3 by 4. These are called fractional numbers, isn't it? 1 by 4, quarter, half or 3/4. So, in every two integer number, there is a non-integer number is known as fractions or decimal. Every two integers, there is a non-integer numbers are known as fractions or decimals. Once again, I repeat this. Every two integers, there is a non-integer numbers are known as fractions or decimals. So, this entire fraction, fractions, decimals and integers are called rational numbers. Please understand this. Entire fractions, decimals and integers are called rational numbers. Okay. Any rational number can can be written as fraction number. Any rational number can be written as fraction number. Okay. Now I am going to say the definition of rational number. Definition. If you have pencil or if you have a pen and note, please note down the definition of rational number. The collection of all numbers, that can be written as in the form of P by Q is called rational number. See, the collection of all numbers that can be written as in the form of P by Q is called rational number, where P and Q are integers, and one important thing is Q should not be equal to 0. This is very, very important. Q is not equal to 0, should not be equal to 0. Okay, once again I repeat this. The collection of all numbers that can be written as in the form of P by Q is called rational number, where P and Q are integers. Q should not be 0. This is called rational number. Okay, can you understand, guys? Okay, now how can you denoted the rational number on a number line? Rational number on a number line. Okay, we find out. We already know that we can easily denoted the whole integers in the on a number line. So now the rational numbers. Okay, so for example, I put 3 by 4. How can you denote the 3 by 4 on a number line? We know this is called 3 parts out of 4. Isn't it, ma? 3 by 4 means nothing but 3 parts out of 4. Okay, so now I draw the number line. So 0, minus 1, minus 2, minus 3, 1, 2, 3, 4. We very well know that 3 by 4 is greater than 0 and lesser than 1. Isn't it, ma? That 3 by 4 is greater than 0 and lesser than 1. Greater than 0 and also lesser than 1. So this 3 by 4, it should be lies only in between the 0 and 1. How can you denote this 3 by 4 on a number line? Okay, so I'll draw it clearly. So we know that in between the 0 and 1. So that is 4 equal parts. 1, 2, 3, 4. 4 equal parts. How many? 3. So this one is 3. So this is 3 by 4. So 3 by 4 is represented in the where lies between that 0 and 1, the third line, 3 by 4. So this is 3 by 4. Can you understand this? So this is, and one more example is, for example, I put 18 by 5. 18 by 5. What is the difference between the above sum and this sum? This is the proper fraction, isn't it, ma? So proper fraction means we can easily find out where it lies. But one problem in this improper fraction, because we can directly represent that 18 by 5 on a number line. So first we have to convert it as a mixed fraction. How we know that 18 by 5 is an improper fraction? We can easily convert this improper fraction as mixed fraction. It's nothing but 3 by 5. Isn't it? 5 3s are 15. 15 plus 3, 18. So 18 by 5. So now we have to find out where it lies. So okay. So I'll again put the number line. 0, minus 1, minus 2, minus 3. We know very well about that. This 3 by 5 is 3. It is greater than 3 and lesser than 4. So it definitely lies in between the 3 and 4. So 1, 2, 3. I'll put the 4 here, where we have to find out. So this is 3 by 5. It is divided into 5 equal parts. It is divided into 5 equal parts. 5 equal parts. So 1, 2, 1, 2, 3, 4. So where we have to find out this. Okay. We have to find where we have to find out this. So 1, 2, 3. So this is 3 by 5. So 3 by 5. So 18 by 5. It is divided. Now we converted as mixed fraction 3 by 5. So it is divided into 5 equal parts. So it lies definitely. It should be lies in between the 3 and 4. So the third marked line. So 3 by 5. Okay. Can you understand this? Yeah. Shall I go to the next one? The next one is writing a decimal as a decimal as rational number. Writing a decimal as rational number. How we find out writing a decimal number as rational number? For example, I'll put 5.4. Okay. How can you convert it as a rational number? 5.4 is nothing but 54 by 10. Isn't it, ma? We already learned in the class 7. No, the decimal. How you convert this decimal as fraction or fraction to decimal, that we know very well about in the previous classes. So 5.4 is nothing but 54 by 10. Now we can easily reduce this fraction, isn't it? How many times? 27 times. This is 5. So 27 by 5. It is a rational number. So 27 by 5, or otherwise you can convert it as a mixed fraction. 5 2 by 5. 5 2 by 5. 5 is 25. 25 by 2 is 27. So 27 by 5. It is also a rational number. So 5.4 is changed as 54 by 10. Then I can reduce this fraction in the simplest form. So 27 by 5. So 27 by 5 is nothing but it is an improper fraction. So we can easily convert it as a mixed fraction. So 27 by 5 or 5 2 by 5. So it is a rational number. The next one is, for example, or otherwise 1.15. 1.15. Okay, is nothing but 115 divided by 100. Isn't it, ma? So we can easily reduce this, because 115 and by 100 we can easily divisible by 5. So how many times? 2 5s are 10, 0. Here 2 5s are 10, balance 1, 3. So it's nothing but 23 by 20. But we cannot reduce this 23 by 20 because it cannot be divisible by both the numbers, you know. So 23 by 20, or otherwise you can draw, or you can change it as a mixed fraction. 1, 3 by 20. 21s are 20. 20 plus 3, 23. So 23 by 20. Can you understand this decimal as rational number? So 5.4 is nothing but 54 by 10. We can cancel this 27 by 5. So 5, 2 by 5. Okay. So 1.15 is nothing but 115 by 100. We reduce this 23 by 20 or 3 by 20. So this is the way to convert the decimal as rational number. Okay. So the next one is comparison of rational number. Comparison of rational. Comparison of rational numbers. What is this comparison of rational numbers? Okay, so we take two rational numbers. It is in fraction, and then it is in negative or positive numbers. So I'll put these two numbers, minus 5 by 4, minus 11 by 7. Can you tell me which one is greater? Yeah. So minus 5 by 4, minus 11 by 7. Minus 11 by minus 7. We can easily cancel this minus. So minus into minus, obviously it will be cancelled. So this one is 11 by 7. Now we have to find out minus 4 by 4, 11 by 7. Which one is greater? Okay. The important thing is, if the denominators are same, means we can easily find out which one is greater. But here both the denominators are varying. Here is 4 or here is 7. So the denominators are not same. So we should take the LCM. 4 and 7. It is not, 4 and 7 is not a common divisible. No. So 4 into the LCM. LCM is 4 into 7 is equal to 28. That's all. So the LCM is 28. Now we take this here. If you multiply by 7 means you will get 28. Isn't it, ma? So 4 7s are 28. The same way in the numerator also. So minus 5 into 7 is minus 35. The same way here, 11 by 7. If you multiply with 4, you will get 28. So 7 4s are 28. So 11 4s are 44. Here minus 35 by 28, then 44 by 28. Now we can easily say this, which one is greater? No, here the denominators are same. Here one is negative number and one is positive number. Obviously positive number is a greater number. So 44 by 28 is greater. So minus 35 by 28 is lesser. 44 by 28 is greater. So clearly by sum, which one is greater? Minus 11 by minus 7 is greater, or else 11 by 7 is greater. Okay. So once again I will repeat this sum. Minus 5 by 4 minus 11 by minus 7. Here both the numerator and denominator having minus. So we can easily cancel this. So the answer is 11 by 7. And one more thing, the denominators are not same. So let me take the LCM. So 4 into 7 is 28. So minus 5 by 4. 4 with 7 only we will get the 28. So 4 into 7 is 28. The same way you multiply by 7 in the numerator also, on the numerator also. So minus 35 by 28. Again 11 by 7. You have to multiply by 4, then only you will get 28. So 7 into 4 is 28. 11 into 4 is 44. Now it's very clearly minus 35 by 28, 44 by 28. One is negative and another is positive. So obviously positive is a greater number. So 44 by 28 is greater. So clearly in the sum, minus 11 by minus 7 is greater, or 11 by 7 is greater. Okay. So children, now we recall what we learned in this session. So first one is rational number. The topic, today's topic is rational number. So every two integers, that is a non-integer number, it is called fraction as fraction or decimal. So entire fraction, decimal and integers are known as rational number. It is in the form of P by Q, whereas P and Q are integers. Q should not be equal to 0, that is Q is not equal to 0. Okay, so that we learned. Then how we denoted the rational number on a number line, both the proper or improper fraction. The next one is how can we convert decimal as fraction? 5.4. Some sums we done it, no? Okay. Then comparison of rational numbers. Comparison of if two rational numbers means which one is greater, we find out. If the denominators are not same means we have to find out the LCM. Then then we can find out which one is greater. So this is the end of this session. Tomorrow we will continue the addition, subtraction, multiplication of the rational numbers. Okay, I hope you all understand this. Can you just look after the PDF in your PDF format? You just download your book and refer this. Okay, thank you.